Hey guys, it's Danny with Part Engineering. Welcome back. And today what we're going to be covering is how to install Kong Mesh on OpenShift 4.12. So we're really happy to announce that the Kong Mesh UBI images are certified in the Red Hat ecosystem. And what that means is that you can go into the Red Hat container catalog and reference those images for your Kong Mesh install. So with that, we thought it'd be great to go through a quick tutorial about how to get started with Kong Mesh and OpenShift. So what we're going to be doing today is understanding how to reference those certified images when we execute the Helm install. The second thing is that for OpenShift, the Kong Mesh sidecars do require a customized security context constraint in order to work within the constraints of, security constraints of OpenShift. So we need to implement that before we onboard any microservices. Once these two items are done, we're now ready to onboard applications. So we'll be using Kick, Kong's Kubernetes ingress controller, as to expose our applications outside the cluster. And then we need a sample application. Book info is really popular, so we'll be deploying a pared down book info for the demo. I do want to highlight that we don't need a license to get started. Kong Mesh can run in evaluation mode. It gives you five data planes. And so book info has been pared down so that we have just enough data planes to run everything. And for prerequisites, you do need an OpenShift cluster. I will be spinning up a Rosa. I have a Rosa 4.12 cluster already up and running. If you do need a cluster, I've left some rudimentary instructions here for you to get started. You do need kube cuddle CLI, the OC CLI, and Helm 3 is the Helm version of Helm that we're going to be using today. So with that, let's go ahead and get started with the installation. I'm going to bring K9S here up top so we can just watch what's going on inside the cluster. First, we got to create the namespace for Kong Mesh. I'm going to go ahead and create that. The second thing is that in order to pull the images from the Red Hat container registry, we do need to create a pull secret. So if you need to go ahead and create one handy. I've left a scaffold for you here, but I'm going to go ahead and take mine and copy it in. And then once that's in place, the last thing we need to do before we really start kicking off the install is we have a couple of jobs that help manage our CRDs. So we just need to run, they do need non-root v2 SEC context. So this command here is just allowing those service accounts access to the non-root v2. And with that, the next thing we need to do is make sure that you've pulled down the latest charts. I've already got it, yeah. And now we're ready to install, but before we install, I do want to go over the setup of the values file really quickly, just so that we're all on the same page. Up to the top here. So from the top, one of the most important, the first thing that we really want to talk about is how do we reference those images? So lines 3, 4, 6, and 7. This is the registry. This is the registry where all the images are. You can see it's pointing to Red Hat. We also need to know the version. So we're going to be pulling down for all images because we've got a control plane image, a data plane image, CNI. They're all tagged with 2.2.0. And then the last thing is the image pull secret. So we just define that image pull secret in the namespace, but we do need to tell the Helm chart which image pull secret to use. The next thing I want to talk about is the security context constraints for the sidecars. So in line 214, what we've done is we're actually providing an additional environment variable to the control plane called the injector container patch. And what this is going to do is allow us to pass in all of these sidecars that are going to be a part of the mesh, right? Need to have the patch. And we don't want to have to annotate every single microservice that we want with the patch. So what we're going to be doing is actually what this environment variable does is that we have a custom CRD. It's going to be called default container patch, and Kong Mesh is going to know to provision this patch to all of the sidecars so that we don't have to do it manually. What that CRD looks like is it's right here in the name in the Git repository. So it's a CRD container patch. It actually needs to go to the Kong Mesh system, and we've called it default container patch. You can see what it's doing is it's just adding some Linux capabilities so that the sidecar can properly run within the security constraints of OpenShift. Okay, so with that, let's go ahead and run through the install. I'm actually going to navigate back up to the README, copy this install command for Helm, Go ahead and run that. And we should be able to go to the namespaces. Should be able to see Cog Mesh System and watch the pods come up. So the first thing is there's going to be CRD jobs that are going to run. So that's what we're seeing right now. We're seeing install CRD. I think we're also following that. We're going to see the patch job run. The other thing is you are seeing a lot of warnings come up. We can, if we had wanted to, we could have corrected that in the Helm chart just to define the correct default SCC for a lot of these a lot of these extra jobs. So that's just something that we could have configured. I was just trying to, the reason why I didn't do it is because I wanted you guys to just see like the values file with as minimal changes as possible, right? Sometimes when there's too many changes, we can't track why, what, when, how. Okay, cool. So now looking at K9S, we can see the control planes coming up. Let's take a look at the logs, and it looks like it's ready to go. Just gonna widen this out. Cool. So we're ready to go to the next step. So what have we talked about? We did the install. We talked about the security context constraint, how the patch is going to be implemented. The last thing, so the control plane is officially running, but before we get to that step, I do want you guys to go ahead and run these two commands down here for one, making sure that the SCC manifest has been applied to the cluster, and that the Cog Mesh control plane has the container patch CRD. So let's just go ahead and do that. It's been created and container patch is created. So if we do kube cuddle get container patch in the right namespace, would be great. You can see it's there. At top for the control plane, the other thing I want to point out is we can just confirm we're pulling the images from the Red Hat container catalog as well. Okay, so let's just double check the UI. We're just gonna port forward because this is a demo, just to save a little bit on resources. Not spin up another load balancer. So execute the port forward command in the terminal, and then you can just copy this to go to localhost. And then from the browser, what we can see is the mesh. We can see we're in evaluation mode in the top here. And in the top right corner, we can also just confirm that we're in Cog Mesh 2.20 Kubernetes standalone mode. Cool. But on the left-hand panel, you can see we don't have any data planes, we don't have any gateways. We have a default. We have the default mesh, and we've got some default policies. The policies are really just to make sure, that everything can talk to each other in the beginning while you're kind of familiarizing yourself with mesh. Can you disable that? Yes, you can. But we're going to keep it on. Okay, so we are ready to get on to the next step of deploying Kick. For brevity, because this isn't really to talk too in detail about using Kick, I just kind of concatenated all the instructions together. But we need to create the namespace, Cog. We need to label the namespace so that the control plane knows to inject a sidecar. There's two options for doing this. We could have labeled the namespace, or we could have provided the label to any deployment manifest if we wanted to be more granular. But namespace is definitely just fast. And the last step is that for service accounts, service accounts that need the sidecar need to have permission to use the security context constraint. And so that's what this last policy command is doing. Now that that's ready, go ahead and grab the chart, do an update, and run. And now we're going to run the install. So I'm just going to copy the Helm install for Kick and run that install. So while this is running, let's talk about these pod annotations. So the first annotation is saying Cog Mesh has the concept of multi-tenancy. So we can have multiple meshes actually running within the one control plane. And so this is saying to join the default mesh. I think I could still show you even though see we're on default mesh if you're looking at the UI. And then the second annotation is that we need to tell the control plane that this microservice, this service is actually intended to be a gateway. So we have to give it that annotation of, yes, this is gateway enabled. Okay, we can go ahead and in K9S, we're just going to check how the deployment's going. Go to namespace Kong. We can see that there's 3 of 3 pods. That's correct. So those pods are ingress controller and proxy. Ingress controller is Kick. Proxy is actual Kong gateway, the actual Kong gateway. So if we open it up and look at the logs, those are the Kong gateway logs. Ingress controller. And then the third one is the sidecar. And you can see if we're looking at the image, it says UBI, Kuma, DP, data plane. Data plane, sidecar, synonyms. Okay, and then we just want to do a quick validation that everything is working. So I'm going to copy this export command to the terminal just to get the IP of the load balancer and do a quick curl. Do a quick curl. You should see, yeah, no route matches with those values. That's just a quick way we do just to test that everything's hooked up properly. Okay, now book info. So Kik's onboarded. Book info. Same thing. The first thing that we're going to do is that all of the service accounts who are going to be part of the mesh. So in this case for book info, it's got the detailed service count, product page ratings, and reviews. All of these guys, they need to have permission to use that Kong mesh sidecar security context constraint. So we're just going to give them permission to do that. And actually, you know what we should do is we should see how that looks when the pods are actually deployed. We'll go in there and review what it looks like. So let's go ahead and create the kube cuddle namespace. Create the namespace. Again, we're going to add the label to the namespace so that the control plane knows to inject sidecars. Let's get out of here. Let's go to book info. And now we can go ahead and deploy book info. So I pared it down, right? So please use the one inside this Git repository because we didn't have, in evaluation mode, we only have so many data planes. Okay, let's go to book info, namespace now from K9S. Only got one pod running. Oh, you know why? There is a mistake in this label. We did not label book info. Look at us finding bugs. Good job. Let me just correct this. So let's correct the command kube cuddle label namespace Kong. We already did that. We actually need to label book info, the injection. Now we'll do, we need to delete all the pods. Book info. And now you can see as they're coming up in K9S, there is a second pod. And they are coming up one at a time. Let's take a look at that SCC a little bit more really quickly. So what I'm going to do is I'm just going to open up as an edit mode to see the manifest, and I'm going to look for a security context. The first one that comes up is, so we're not crazy, name, Kuma sidecar. So the sidecar, right? DP, sidecar, synonyms. And you can see the security context constraint is, we didn't have to define all of these because a couple of the UID, the GID run as non-root. That's all default, but we did and drop all is default, but we did have to add these 4 capabilities here. But, right, this is not something that we want to provision default to all of our containers running in the pod. So if we look at the actual microservice, in this case, book info details, and we look at its security context, it is just the default security context constraint for a microservice. So that's perfect. That's exactly what we're looking for. So just close that. Okay, we can see all of the pods are running. And so we now need to create an ingress resource to expose everything. That's created, and we need to go to the browser. So what I'm going to do is I'm just going to echo out proxy IP. Grab this load balancer. And we're going to go to the browser. This is product. Oops. This is product page. And there we go. Book info is, for most of 90% of intensive purposes, up and running. Sign in works. Yeah, never. Sign out works. We're missing a couple of things, you know, because it had to work. And, you know, before we go, let's go ahead and check out the control plane as well. So let's port forward again. Forwarding's up. Let's go back to the browser and see what we got going on here. So we didn't do anything with policies, right? We're just kind of getting everything up and running. But we can see that there's 5 services. We've got the microservices, our Kong ingress controller, and product page, ratings, reviews, and details. And we do segregate them within the UI as well, right? So if you wanted to just look at your gateways, there's the gateways tab. Just want to see the data planes that are not behaving as a gateway, you know, we're protecting with the mesh, then you go to the data planes proxies. there you have it. That's what we needed to do to go ahead and install Kong Mesh on OpenShift 4.12. That's it. To go ahead and uninstall, I've left you some cleanup instructions. Go ahead and clean that up. And if you're using Rosa, go ahead and delete your cluster. And thanks for making it to the end. If there's any questions at all, please feel free. This is an open repository. So open up an issue and let us know if there's any questions. Thanks so much for your time. See y'all later.